Three machines can cut the same steel plate, and the cheapest one per part is usually not the one people reach for. By the end of this, you will know which of guillotine, plasma, or laser your thickness and tolerance actually point to, and the single question that decides it before cost ever comes into it. Start with the guillotine, because it is the only one of the three that cuts cold. An upper blade comes down past a lower blade with a small gap between them, called the blade clearance. The metal is not melted or burned. It is pushed until it plastically deforms and then fractures along the line of the two edges. That is why a sheared edge has a signature. Look at it end on, and you see a rounded rollover where the blade first pressed in, a bright burnished band where the metal was cut cleanly, a rougher fracture zone below it, and a burr on the underside. Get the clearance wrong for the thickness, and that fracture zone grows, the burr gets worse, and the edge starts to look torn. The guillotine also has hard limits. It cuts straight lines only. The blade is set at a rake angle, so it cuts progressively rather than all at once, and that same angle twists narrow strips as they are cut. Machine capacity is quoted in mild steel, so cutting a stronger material like stainless means derating the thickness. What you get in return is no heat-affected zone, and the lowest running cost of the three. Plasma is the opposite approach. An electric arc is struck between an electrode and the plate and forced through a small nozzle, which constricts it into a jet hot enough to melt the metal. The same gas flow blows the molten metal out of the cut. It only works on electrically conductive material, and it is genuinely fast once the plate gets thick. The trade is edge quality. A plasma kerf is wide compared with a laser. The swirling gas leaves one side of the cut squarer than the other, so the edge carries a bevel, and there is usually some dross underneath to grind off. There is also a visible heat-affected zone. Nozzles and electrodes are consumables, and as they wear the cut, quality drifts before anything obviously fails. A fiber laser sits at the other end of the scale. The beam is focused to a spot far smaller than a plasma jet, so the kerf is a fraction of a millimeter, the edge comes out close to square, and the cut path can be any shape the programmer wants. Holes, slots, and tight internal corners cost nothing extra beyond cutting time. But the laser has a thickness wall. Cutting speed falls away sharply as plate gets thicker, and above the range where nitrogen still works, the machine switches to oxygen cutting, where the iron itself burns and adds heat to the cut. That gives you thickness, at the cost of an oxidized edge and a much slower feed rate. Thick plate on a laser is possible. It is just not where a laser earns its money. Now think about what happens after the cut, because that is where the real cost hides. A sheared edge needs deburring, but has no hardened layer. A plasma edge usually needs dross removed and the bevel allowed for. Both thermal processes leave a heat-affected zone, and if you bend along that edge or tap a hole near it, harder material is waiting for you. Distortion matters too. Concentrated heat in thin plate pulls parts out of flat, while shearing pulls narrow strips out of straight. So here is the decision map. Straight rectangular blanks in plate to a workshop tolerance with volume. The guillotine wins on cost per cut, and it is not close. Profiles in thick plate where a couple of millimeters either way does not matter. Plasma, and the thicker the plate, the stronger that case gets. Complex shapes, tight tolerance, small holes, or anything that goes straight to assembly or machining without cleanup. Laser. And if the part cannot tolerate any heat at all, none of the three is your answer. Water jet is. The question that settles it before cost does is simple. What does the edge have to be when it leaves the machine? Answer that honestly, then pick the process that gets there without a second operation. Most shops that argue about cost per meter are really paying for grinding they never costed. Next time, why sheet metal springs back after you bend it, and how to beat it.